Okay, good morning, everyone, or good afternoon. Okay, so today we will try to continue our topics on the calculus 2, especially for a double fold integral. Okay, so previously we discussed about this type of questions. Okay, this one. So how can we calculate this double two-fold integral? Okay, let's say dx dy. And then in the previous video, I explained is about what is actually a Riemann sum, the intuitive of the double integral. Okay, the two-fold integral, or I call it as a double integral. What is actually its means, which is actually a volume above these functions. And then in the Riemann sum representations, how can we representing it? I also try to illustrate it by that. So this one is actually a bread, and then we cut it into pieces, and then we cut cubes, which is actually this one, and then we sum everything. So, okay, that's what's happened in the double integral. So in summary, let's say if we take a limits and then the cubes becomes very small, then we can get into this what we call it as a two-fold integral. Okay, this one. And then this is a geometrical representations uh, of the two-fold integral. So we have these assumptions. So this one is should be assumed. Fx should be continue and then positive in let's say this is the domain R, and then this one is actually a volume of solid. Okay, volume of solid that is above the surface. What this is the functions. Okay, and then this is the domain of the function itself. Okay, this is what we have discussed previously. Okay, I will not go into this one again, but I will try to continue again actually our material. Okay, so this one is also if we slice it, we slice these functions in differently. The first one in we slice it with respect to x, and then now with respect to y. Okay, but this is actually the representations of that. Okay, so this is what we discussed in the whiteboard previously. If we calculate this integral, okay, and then we calculate on the domain of R. Let's say this is R that is defined in these figures. Okay, so how can we do that? We can do that either calculating the integral in y first and then x. Okay, also the other way around, this one resulting 544, and then the other one we integrate it in x first. Okay, and then later on we integrate it with respect to y, and then we get the same result, which is actually 544. Okay, we discussed this actually in the whiteboard, but now I will try to continue this material. I will try to continue this material again. Okay, I will put my camera here so that I can see directly into the camera. Okay, so we will try to discuss another examples of this one. Okay, I will go now into my whiteboard. Okay, let's go to my whiteboard. Okay, so for example, example 2. Okay, so for example, calculate the following double integral. which is actually sinusoidal of x plus y, and then dA. A stands for the area, okay? And then where this is within the area R, what we call it is a R, and then R is defined as as follows, okay? This is actually a set of point x and y with conditions, okay? X is between 0 and pi over 2, and then y is defined between 0 and also pi over 2, okay? This one. How can we calculate it first? First of all, the answer is we should check the area of the R itself, okay? So we write down the R itself. What is the R actually? The domain of these functions itself. This is X, this is Y, and then I will try to write it down. The area of R, X, it's between 0 until pi over 2. So this one is pi over 2 from 0, okay? And then y is between also the same from 0 to pi over 2. So what can you guess? The area is actually a rectangle, okay? This is actually the R. What we call it as R. Okay, we'll try to write it down here. This is R. Okay, now how can we calculate it? First of all, we write down the integral first. This is what we would like to calculate. This is integral of sinusoidal x plus y dA. I rewrite it again here with respect to R, and then now we break it down into the x and y. Okay, so first of all, what do you want to would like to calculate? I would like to calculate in x first, okay? Because this is a rectangle. This is quite easy domain, let's say. We will try to discuss it more complex domain in the next meeting. I will try to calculate it first in the x, okay? So I write down the function itself, x plus y, dx, dy. Now remember the boundary of the x and y itself. X is between 0 and pi over 2, and then also the same for the y, okay, pi over 2. Okay, now we integrated this one with respect to, we'll try to write it down in the different color, okay? We will try to integrate the things in this yellow one, okay? We try to integrate with respect to x. What does it mean? Other variables, if any, than x, we consider it as constants, okay? What does it mean? So the y, we consider it as a constant, okay? So we integrate the sinusoidal here. The integral of sinusoidal is actually minus, sorry, I will use another color. I came back to the, sorry, I pushed the wrong button. So this one is C, cosinus. Okay, this is minus of cosinus, cosinus of x plus y. And then I integrated from 0. This is x from 0 until x until pi over 2. Sorry, I push it again. Okay, 2 and dy. Okay, over this one, and this is pi over 2. Okay, and then just simply substitute the value itself. X is pi over 2, and then x is 0. Okay, remember y is still to be a constant. Okay, we do not do anything with that. I will write down again the boundary for the y itself, and then cosinus minus of cosinus pi over 2 plus y, okay, this one, and then minus is plus, okay, become cosinus of 0 plus y, okay, this is 0 plus y, and then I write down only y, okay, so this one is actually dy. So what do we have? Okay, we still have something with respect to y. Okay, now we do the integrations with respect to y. Okay, the integral of a cosinus, which is actually sinusoidal, sinus of pi over 2 plus y. Okay, sorry, is that correct? Sorry, yeah, sinusoidal. So cosinus, yes, the integral of cosinus, which is actually sinus over pi over 2 plus y, and then this one is become plus, okay, sinus of y, and then now the boundary y is from 0 until pi over 2, okay. Now I simply substitute the y is pi over 2. This is become sinus of pi over 2. This is pi over 2 plus pi over 2, which is actually pi, but I write down here to make it more clear, and then sinus of pi over 2, and then minus, okay, now it's become this one, minus sinus of pi over 2, because y is 0 now, and then plus sinus of 0, okay. So what do we have? If you do not remember, I will try to remind you. This is how actually the sinusoidal looks like. Okay, I will put it more larger here. So this one is a pi, this is 2 pi, this is x, okay. So this one, the blue one, is in a sinusoidal, okay. Of course, this is to the left, to the negative, x negative, okay. And then this is 0, okay. Sinus of pi, what do we have? Sinus of pi is 0. Sinus of pi over 2, here, pi over 2, which is 1, okay. This is 1, and then this is become 1, this is also 1, this is 0, okay. So what do we have? We have 1, this is minus plus, sorry, plus 1, and this become 2, okay, finish. Okay, so I recap again. This is calculate. Okay, so we calculate this type of form of the integrations. What you see is actually, this is the domain, which is actually the rectangle. Don't worry if it is rectangle, this is the easiest one. You can either start with the x or start with the y, doesn't matter, okay. And then we got these results, okay. So we will check in our slide. So this is our slide. This is what we have done on the whiteboard. So we got this is 2, okay. And then to make it more easier for you, please try to do this at home for your exercises, okay. This one is the integrations. This is relatively easy. First, let me try to remind you, if you do it in the y first, and then you consider the x as a constant. The other way around, if you consider we integrate first in the y, then we treat the x as a constant. Okay, exactly the same idea for the number 2. Now we go to another topics. Okay, so I have prepared actually here. So this is actually, I take it from books actually here. The properties of the double integral. Okay, the double integral inherits most of the properties of the single integral. Okay, first of all, okay, the double integral is linear. What is it? Actually, linear. Okay, if you put a constant like a k here, if you put a constant like a k here in the front of the function, you can take it out, okay, from the integral, just as it is. Okay, this is exactly the same in the in the single integral. Okay, and then this is for the constants, and then also for the additions. Okay, you can distribute. So the some additions like these functions fx plus the gx, we can split it and then we integrate it each functions. Okay, it's function like this. So this is what we call it as a linearity of an operator. So a double integral is also a linear operator, what we call it. Okay, what is actually the second property of the double integral? So the double integral is additive on rectangle. Okay, that overlap only on the line segment. For example, okay, so for example, I will try to illustrate it in 1D. Okay, I will try to illustrate in 1D. So for example, this one, this is the function, this is our functions. Okay, this is our function here, somewhere here, and then I will split the domain into 2 parts. Okay, let's say this is A, this is B, this is C, and this one, well, the black one, I mean, the black one is actually function of fx. I illustrated in the 1D so that you can easily imagine it. Okay, so what is actually the integral of fx? Sorry, I push it again. Okay, yeah, dx from A to C, A to C. So how can we define it? So we can split it into different domains. Okay, either directly, or we just split it here from A to B, and then we add it with the B to C, exactly the same. Okay, so from A to B, this is fx dx, and then we add with the rest of it, which is actually integral from B to C of fx. Okay, what we call it as an additive, exactly the same idea for 2 dimensions. Okay, exactly the same. So the third one is actually comparisons. The comparison property holds. Okay, so for example, f, the function f and g, f is is less than equal to g function of x and y for every, okay, for every x and y in the R is the domain itself. Okay, and then the result of the integral is also holds. Okay, so if the function is f, let's say f is less than equal to g, and then the integral, the double integral of f with respect to the same area R is also less than equal to g. Okay, this one. Okay, this is exactly the same comparisons as in 1D. Okay, that's it actually. So we proceed. So now we will talk about what I will go back to our slides. Okay, so we will go back. I will go to our slides. This is what it is written in Indonesia. What I just explained in the whiteboard. Okay, now I will try. What if? Okay, what if the integrations is not on a rectangle, a simple rectangle as we just discussed. Okay, but now in the arbitrary domain. Okay, let me try to explain to you. There are two types. Okay, let's say I will try to write it down here. This is type 1. Type 1. So type 1 is actually x are fixed. Okay, the boundary of x is fixed. Okay, but the boundary for the y is limited, is bounded by a functions, by two functions. Let's say this is px and qx. Okay, number two, type number two, actually the domain itself, the x is now bounded by the functions, bounded, bounded, okay, by functions. Okay, the type 2, the y is fixed from C to D, let's say from C to D, but the boundary for x is bounded by functions. In this case, the function itself is r, function of y, and s is function of y. Okay, remember this. If y, type 1, I will try to use a pointer now. Here, in type 1, x is fixed, but the y is limited or bounded by functions of x. Okay, type number 2, y are fixed. Okay, the boundary of y is fixed. Okay, but it is the boundary of x are bounded by functions in y. Okay, we will take a look some illustrations. So this is the illustrations for type 1. Remember, type 1, x is fixed. So the x itself, it is actually from A to B. Okay, from A to B. The x is fixed here, but the boundary of y is limited or bounded by function, but the function itself, it depends on x. Okay, this is type 1. Okay, this is the illustration itself. So it is of course this is line because it is fixed by a number, and then this one is limited by functions. Okay, so how can we calculate the double integral here? We can calculate it by using the following by following formula. What can we calculate first? If the x is fixed, okay, put it in the outside of the integrations domain. Okay, sorry, we calculate first in put a pen here. We first calculate the y. Okay, if type 1, which is actually x fixed, okay, we first calculate in y. Okay, I will repeat that. And then the second one, we calculate it with respect to x. What if it is you did it wrong? It is simply doesn't work. Okay, that's simply doesn't work. So that is actually type 1. I will try to explain also now the type 2 here. So this is a type 2. What is a type 2 actually? The type 2 is actually boundary in Y is fixed, okay, from C to D, okay, from C to D, but the boundary in X are limited or are bounded by functions, but the function itself is a function in Y, okay, remember this one. Okay, see, this is how we write down the domain itself. D is actually this one, and the C is this one, okay. So how can we calculate the double integral of this one? So the double integral, if the Y are fixed, okay, remember, we calculate first the X, okay, and then later on we calculate first this one, and then the other one, this is in Y, okay. Of course, this is not to be remembered like a formula, but this is some kind of logics, okay. This is a rule of integration, so we'll try to discuss it in the next slide. So this is a rule of integrations. So the sequence of the integrations in the double integral is depends on the shape of the integration area or the domain of the function itself, okay. In the calculations, usually we need to change in the calculations, okay. This is try to remember, we need to change the order of the integrations. We maybe need to change it to make it more easier, okay. This can be caused by changing of the integrations. Maybe this can be make the calculations is more easier than directly. So it is we will try to do it in the next slides, okay. I will try to pause it now. Okay, now we continue. So point number 3. So in the first step, what should we do? Actually, we try to draw the graphics, okay, to draw the area of the integrations itself, so to make us easier to calculate either in integration in the X first or in the Y, okay. And then we will see, okay. So we will try to do some examples on a whiteboard here. So examples, I will try to do some examples. So this is some example. Example number 1. Okay, calculate the following integral. So let's say this is 2y e to the power of x, and then with respect to dA, A is the area, and then the domain itself is R. R is bounded. Okay, is bounded by so it is bounded by x is x squared, y is 1, and y axis, okay. So there are 3 boundaries. X is a y square, y is 1, and then y axis, okay. Or we can rewrite it like this. R, it is actually a set of x and y with conditions. X squared, x is bounded by x is bounded by y square. This is y square, and then 0, and then y itself is bounded by 0 to 1. Okay, where do we get this? Okay, where do we get this? We try to calculate it first. We try to draw it, the function itself. First of all, first boundary, x is y squared. Okay, we first draw it here. X is y squared is something like here, this one, and then y is 1. Y is 1. Okay, this is x, this is y is 1. Let's say something here. I'll put it here. Y is 1 is this one. Okay, and then y axis is this one. Sorry, I did something wrong. This is not y is x squared, but the x is y squared. Okay, I will try to erase it, everything. I redraw it again, redraw it. Sorry for that one. So this is x is y squared. Okay, so what we got is actually we flipped it. We flipped the parabolic function that we always know, which is actually this one, what I did previously. So this one is actually x is y squared, something like this. Okay, and then y is 1. Y is 1 is something like here. Let's say this is 1. Okay, and then y-axis, where is it? This one. Okay, this is y-axis. So where is the area? This is actually the area that we are trying to calculate here. So okay, so this one that we actually draw, because this is a 1, and then we just simply square it to 1, then this become 1. Okay, so I try to zoom in first. Okay, zoom in. I'll try to zoom in. So it looks like something like this one. I'll put it, I will zoom in. Let's say, sorry. I will put it here. Okay. So this is the area that we are looking at for. So this one is a 1. This is 1. Okay. So now we know this is y. This is x. Now we know x is from this is the x. Okay. So we can define it. Okay. If we slice it horizontally or vertically, so it depends on the problem itself. Either you would like to calculate in the x first or in the y first. Okay, first try. Okay, this is first attempt. Okay, we will try to calculate it by using, this is 2y e to the power of x. Okay, we calculate it first in the, let's say x first. Okay, and then y. Okay, so in the x first, the y should be constant. What is y? Y is from 0 until 1. Okay, from 0 until 1. But the x itself is not constant. From where? X is from here, okay, until here. Okay, let's say this is from 0, because this is 0, from 0 until this graph, the red graph here. What is the graph here? The graph here is x equal to x squared. Now we get the following, this one. Okay, then we got this one. So the x is defined between 0 until this graph. X is y squared with this one, okay? So we put it in here. So x is from 0 until, remember the first type, if y is constant, if y is constant, then x should be depends on the function in y, okay? Try to remember in the previous rules. So this one is become y squared, okay, and then y is from 0 until 1. Now we concentrate on these integrations, okay? We will try to calculate it here. So what do we have? First of all, we would like to calculate this x and then y, okay? When calculating this with respect to x, the y, we consider it as a constant, okay? Try to remember it. I will try to write down the outer integral, which is actually y. I integrate 2y e to the power of x with respect to x, okay? 2y, this is constant, I just put it in. And then e to the power of x, I integrated, I got the same, okay? And then the boundary now, the boundary is x from 0 until x is y squared. What do we have? This is dy, okay? So we calculated first. I'll first try to substitute the function itself here. So what do we have? We have 2y e to the power of y squared. I just simply substitute it. And then minus 2y e to the power of 0, which is actually 1. Okay, I do not put it here. E to the power of 0, which is actually 1. Okay. And then this is 2y dy. Okay. And then I will try to calculate it with respect to simply integrate it here with respect to y. Okay, I will so just to remind you, what is actually the integral of 2y e to the power of y squared? How can we calculate it? We use substitution method. Okay, let's consider u as a u squared, and then du is actually d to u to y, sorry, to y dy. Okay, and then dy is 1 over 2y du. I just simply substitute it here. What do we get? This is 2y e to the power of eu, and then dy, I replace it with 1 over 2y du, and then simply erase it. And then what do we have? Put it here. I just simply get eu plus c1. Let's say this is some constant. And then I put it back to y squared. Okay, I replace it, the u with the original y squared. Okay, this is c. So I simply put it here. So what do we have? This is so we have e to the power of y squared, and then 2y we integrate it, which is actually y squared. Okay, and then it is executed at 0 and 1. So what do we have? I just simply put it in e to the power of 1, which is e, and then this is 1, and then minus e to the power of 0, which is actually 1, and then what do we have? E minus 2. That's it. Okay, this is by considering x first. Okay, this is x, but now we will try to continue exactly the same method, the same problem, exactly the same problem, but now we change the order of the integrations. But now we will calculate it in the y first and then x. Okay, let us just try to concentrate on these figures. Okay, I will try to concentrate in these figures. Okay, method number 2. Let's say I call it a method 2. Okay, what is the method? Calculate I will try to put it here. This is 2y e to the power of x dA. But now I calculate it in y and x. Okay. First of all, what do we need to know? First of all, the x should be constants. Okay, this should be a to b. Let's say this as a constant, but this one, the inner the integral in the dy should be a function of x. Let's say this is fx and gx. Let's say something like this. Okay, so now we can determine what is actually fx and gx. Let's just simply try to draw it for again to make it more clear. This is the area that we are looking for. This is from 1 to 1. This is the x, this is y. But now we consider it, x should be constant. So what do we have? X is between 0 until 1. So we got it here. I put simply directly here. So we have 0 until 1 for the x. Okay, this is 2y e to the power of x dy. Remember, I do not put anything yet from the dy, but I put from the dx. The x is from 0 until 1. But now how about the y itself? Look at this. The y itself is from where? From this one until this boundary. Okay, from this one, what do we have here? We have actually x is y squared, but you cannot directly calculate it. You cannot say it directly. This is x, this is y squared. Okay, no, because why? We should write it down in the x functions. We should calculate it in the x. We should write it in the x. Okay, so this one we flipped it. So what do we have? This is actually y square root of x. Okay, this is plus minus. The minus one is actually the lower one, but we do not consider it. We consider only the positive one. So we can calculate it. We can write it down as these functions. Okay, so instead of write it down as this one, we calculate it, we write it down as this one. Okay, from where? Sorry, the lower boundary. Okay, square root of x until 1. Okay, that's it. Okay, try to figure out the boundary, the order of the figure of the domain itself first, and then write it down the boundary. Correct. Okay, now we calculate it, but this is a simpler actually. You just have to do it exactly the same idea, and this is 0, 1. Let's do it. Okay, I integrate now with respect to y. What does it mean? The x is considered to be constants. Okay, e to the power of x, this is constants, and then y squared, y 2y, I integrate with respect to y, become y squared. Okay, and then it's the boundary is y is square root of x, y is 1, and then this is the boundary of x itself. So what do we have here? I just simply put it in the y, e to the, so this is 1 times, okay, I will make some spaces here. This is 1 e x, okay, minus x, okay, square root, and then we square it, become x, okay, x e x. Is that right? Yeah. And then this is dx, right? This is a dx. Is that correct? Is that correct? I think so, right? Yeah. Okay. Now we integrated e to the power of x. We integrate exactly the same. This is the ex, and then x e to the power of x. Okay, this is should be not easy. Okay, I will try to remind it you what is actually integral of e to the power of ex dx. Okay, how can we do it? We cannot do it by substitutions. Can you think about it? How can we do it? We calculate it by using partial integrations, I guess. Okay, let's just try it. Integral of u dv is actually u times v, integral of v du. Maybe, okay, I'll just try it, okay. What can we consider as a u? U is actually x, du is 1, and then dv is actually e to the power of x dx, and then v itself is ex. Okay, I will try to continue here. Okay, u, this is x, v is ex minus v, v is actually ex, du is 1, sorry, this is dx. Okay, this is dx. So what do we have here? Ex minus ex plus c. Okay, this one. Then what do we have? I will try to continue in the red here. So what do we have? Integral of this one is become x ex plus ex, and then with boundaries, which is actually x is 0 until x is 1. Okay, so what do we have? Think we are correct. This is e, this is 1 e plus e. Okay, now with the zeros, this is 1 0 1. Okay, what do we have here? I have 2e minus e, which is actually e minus 2. Okay, I got this one. Okay, let us just compare. Okay, that's correct. Okay, so both methods resulting the same result, which is actually e minus 2 and then e minus 2. Okay, that's it for now. I hope you enjoying the video. I hope you are understand it. I will try as a closing. I will try to show you my slides here. This is what we have discussed on the canvas. Exactly the same ideas. I just write it more clear, maybe, on the canvas. Okay, this is so we change the order of the integrations. Okay, and then it's resulting the same values. Okay, e minus 2. Okay, that's it for now. Thank you very much for your attention, for your attendance and attentions. Okay, good night.